Now we will discuss some overview of video description. Similar to image description, the goal of video description is to describe the action event occurring in the video. But the task of a video description is more challenging than the image description because the here we have dynamic content as compared to the image which have just static contents. Basically, depending on the video duration, the description video description include two type of generation process: short video description and the dense video description. In the short video description, video of shorter length are used. Typically, the duration of these clips lie between 10 to 20 seconds. Uh, in the short video description, most of the approaches segment the video into chunks of a frame for better visual encoding, and then describe them all the events into just a single sentence. As we can see in this particular example, the whole video is just described by a single sentence, that is the highlight of a women's soccer match between Japan and their opponent. But they have ignored the events which have occurred in between in this video. That is, the player was dribbling, then he had passed the ball toward his teammate, and who attempt goals toward the goal post. All these events are just ignored. In the short video description, the model is try to generate a generalized description for particular input video. Now the dense video description. In this type, the length of a video is longer than the video used for short video description. Typically, the duration of these clips lie between 5 to 10 minutes, and they include multiple events. And most of the approaches which are proposed for dense video description, they involve firstly the detection of events and the boundary in the video, and then describe them in the more than one sentence. For example, as we can see in this example, firstly the video is divided into multiple overlapping intervals, and then the description for each interval is generated. Before discussing the notable works for video description, let's discuss the structure of a video. Since performance of a video description approaches totally depends on how effectively the visual features are encoded, and it is important to understand the structure of a video because we only know the one thing about the video, that the video is a sequence of a frames which is accompanied by the an audio track. But broadly, there are different three levels in the video, in which we can divide the video hierarchically. It includes scenes, shots, and frames. Based on the content, event, and action occurring in particular video, we can have multiple scenes. Basically, a scene consists of a multiple semantically related and temporally contiguous shots. And the shot is the collection of a continuous similar frames taken uninterruptedly, while the frames represent a single image, or we can see that we can consider it as a basic unit of a video. Uh, to understand this, if we can take an example of a video where the two persons are doing fighting, and for some second, and then suddenly the frame move, the scene change to the another scene where the policeman is approaching to those person, and again the scene change to that fighting scene. So here we will have a three shots, that the person are fighting, then the policeman is approaching those persons, then again the person are fighting. So here we have it will give us a three shots with the repeated shots. We have repetition of the shot, but if we will merge the repeated shots, we will get two scenes which are basically the uh, containing those scenes. The whole video is consist. So in this figure, we can see that the video contains number of similar frames with duplicate information. So the selection of a most informative frame is very crucial in the video description generation process. And now the works which are Same to the image description approaches. Here we have the approaches for video description are also 3 phases, but we will start with the classical method based phase. Basically, the success of image description approaches in generating natural language description for motivates the uh, researchers to generate a description for video as well. But the early work in this domain focus on describing the videos from some specific domains like generating description for surveillance video, or the describing the actions performed by human inside a particular room, or the automatically generating cooking instruction manual for a particular recipe. And the early approaches has 2 stages similar to the image description. Firstly, they have detected the semantic tags for the input video, which include the detection of subject, verb, object, and place. And then using a template or the statistical machine translation approaches, they have generated the description for the input video. This given figure shows the model which is used by the Thomson et al. For generating a description for video in the wild by using a factor graph to combining the visual entity with the language. They have used a visual recognition system to obtain the confidence score on the entities and activities which are present in the input video, as shown in here, and then then they propose a factor graph model that combines the confidence scores with the probabilistic knowledge which is mined from the tax corpora to estimate the most likely subject, verb, and the object related to that particular video. And finally, to generate a description, they have used these subject object triples, subject verb place triple, or the subject verb object quadruple. At the output, we will have some candidate description related to particular input video. To get the best description, they have used a Berkeley language model, and they have re-ranked using that Berkeley model language model all the generated description. Similar to the classical method-based phase, which approaches which we have discussed for image description, they have also these approaches for have also same drawbacks, like they use a templates which use a large number of rules to construct them, and they are not able to address all the possible events which are occurring in particular video. And the first work which are using a deep learning basically proposed by Venugopalan et al. In 2015. In this approach, to encode the visual features of an input image video, they have sampled out 1 frame out of 10 out of the chunks of 10 frames, and then using a pre-trained convolution neural network, the features of each frames are extracted. By performing the mean pooling over the extracted features, the whole each video is just represented by single feature vector, which are passed to the stacked decoder with 2 LSTM layer to generate a sequence of a word. This convolution neural network, which they have used, basically trained over IL SBRC dataset for object classification. It consists of 1.2 million images. But this approach has some drawback, that is, it ignores the temporal structure in which the sequence of the sequence of frame and the action which are occurring temporally, because they are just taking a mean pooling over the all the extracted visual features and representing whole video by single feature vector, which just reduce the problem of video description to the image description. Inspired by the success of a sequence-to-sequence machine translation approach, and to address their and the drawbacks of their previous approaches, in the same year they have proposed a new model which include a 2 LSTM layer. In this framework, for the first several time step, the top LSTM which is shown in the red color, received a sequence of frames and encode them, while the second LSTM received the hidden representation and concatenate it with the null padded words, and which it then encode. And after encoding all the frames, the second layer is fed with the beginning of sentence, which from the decoding process, and the generation of a word in the output is started, which continue until the end of sentence. Special tag is generated or the maximum length of the sentence is reached. But this approach has some drawback, like they have selected only first 80 frames of the video. In that case, there are some videos, many videos which have some main is responsible contents which are appearing after the 80 frames, because in the video we have almost for the 10 to 20 seconds, for the 10 to 20 frames we have a continuous frames which having a similar content. So uh, this uh, this approach will ignoring the content which appear with the after the 80 frames. And as we know that the video is a rich source of information, it involves the multiple modalities, information from multiple modalities, like it include visual features, motion features, and audio features. And most of the existing approaches for video description are sequence to sequence learning based and consider the whole video as a flat sequence. uh, and then the Juetel observed that the different modalities, and as well as the element within each modalities contribute differently in the sentence generation. So they have proposed a multi-attention log short-term memory network, in short MALSTM, to generate a description for input video, in, to including all the multiple modalities. The proposed framework basically exploit the multimodal streams and the temporal attention to selectively focus on a specific element during the generation process. And they have also designed a novel fusion unit, which effectively combines all the different modalities and to the initial decoding stage. And this approach has shown the outperform the previous approaches in generating a description effectively, or the reported the state of the results for input in the video description approaches. Since we know that the deep reinforcement learning approaches outperform the humans in many real-world games, so some researchers have tried to use the capability of reinforcement learning to address the task of a visual description, generating a description for a input video. In the deep reinforcement learning, the model learn from the environment through the trial and errors and adjust the learning using the reward function. So based on the assumption that picking an informative frame from a video can improve the quality of generated description and can also reduce the computational cost, Chanital proposed a deep reinforcement learning based approach for video description generation. In this approach, they have addressed some critical issues like frame selection, as we have already seen that a video include a multiple frames with a similar content. So and the previous approaches give equal weightage to all the frames, and there is no guarantee that the frame selected by equal interval sampling contain meaningful information, because in the video it is possible that the content of that particular frame get affected by the motion blur, uneven illumination, and occlusion effect. So to address this issue and pick informative frame from a video, authors have proposed a PickNet model, which is flexible and efficient. Flexible means that it can be used as an plug and play module for any video related downstream task. Uh, Basically, it was proposed for video description, but that PickNet model can be employed in other video related tasks like video question answering, and etc. And it is efficient because it can largely cut down the number of required video frame for description generation, which we will observe in the upcoming slide, or which from the report which the authors have reported. Since this approach employ reinforcement based learning, so two type of a reward function are employed. that is language reward and the visual diversity reward. Language reward ensure that the pick frame should contain this semantic information, and for that they have used the CEDAR score. And the visual diversity reward ensure that the pick frame should have a good visual diversity. For that they have used the standard deviation of a feature vector. The good visual diversity means that if you will observe this particular figure from frame 1 to 4, the content is almost similar, that the person is about to jump but he have not jumped, but in the fifth frame the person is jumped over the swimming pool. So what visual diversity reward is trying, it is trying to maximize this difference between the frames. If the difference is very less, the frame will not be selected, but if the frame exceed a particular threshold, that the frame will be selected, and finally a feature vector is accepted for the video. In this approach, the training process is split into three stages: supervision stage, reinforcement stage, and adaptation stage. In the supervision stage, the encoder decoder is trained with the traditional approach, that is maximize the likelihood of next ground truth given the previous ground truth. For example, given this type, we will try to maximize the probability of getting this off as an XOR. And in the second stage, they have fixed their encoder decoder and train the PICNet model using reinforcement learning. Finally, in the adaptation stage, they have jointly trained the PICNet model and the encoder decoder into end-to-end fashion. And this table reports the results reported by PICNet model. The highlighted row shows the results of this model, and some key observation which the authors has observed from this approach is that selecting an informative frame can minimize the noise and the unnecessary computation, because since the video have a similar frame, it will be better to select a key informative frames. And the compact set of subset of 6 to 8 frames on average can represent full video, which can be verified from here that the model is using average 8 frames for each video and reporting the comparable results. Although the results are not outperforming the previous approaches, but the results are very comparable by just using just 8 frame per video. And they have also does not employ any multimodalities type of features. They have just used the visual features and reported these results. So from here we can see that this model, this approach is slightly better than the previous approaches, which gave equal weightage to all frames. It select a pick, it picked the informative frame from the video and giving this comparable results. So this model needs some slight modification or fine tuning. It will outperform the other approaches. So till now, the approaches which we have discussed for video description focus on the task of describing the entire video with just a single sentence, not on the detecting the series of events in the video and then describe them. To address these issues, the Ranjay Krishna et al. Propose a benchmark model that is able to identify all the events in the single pass of a video and simultaneously describe all the events using a natural language. To design the model framework for this task, they have faced two major issues: that detection of multiple events in short as well as long sequence of a video, and utilizing the context from the past and concurrent and the future to generate an efficient description. And this figure shows the architecture of the model. To address these challenges, they have employed two modules: the proposal module and the captioning module. Basically, the event proposal module and the captioning module. In the event proposal module, they have firstly used a 3D convolution neural network to extract the visual features for the chunks of a frame. And these features are passed to the deep action proposal module, which employ LSTM. and this proposal module produce K proposal at every time step with start and end time. And after getting all the proposals, the captioning model comes into an action to describe these detected events. And in this captioning models, to capture the context from the neighboring events, they have just categorized the events into two buckets. One bucket contains the information from the past, and the other bucket contains the information regarding the future events. And then finally, using the LSTM, they have generated a sequence of a word. To show the superiority, the model is tested with different variation, like with no context model, full mode, or the online mode. In the no context mode, the model is tested with sequence to sequence fashion without any context. But in the full model, the model is tested with the proposed configuration, and in the online mode, the model is allowed to use the context from the past, not from the future. And from here, from this figure, we can see that the description generated by model using online context mode and in the full context mode. And from here, they have observed that in the full context mode, the model is able to use the knowledge that the vegetables are later mixed in together in the ball. But this description was not generated by this online context mode, which does not use any future context. That is why it was not able to address this that these ingredients are later mixed in the bowl. And this model is also generated some unknown words which was not present in the description generated by full context model. And there's some key observation which are observed by the claimed by the authors that they observe that the performance of a model increases with the addition of both past and future context, which we can observe from the generated description. They have also observed that the model which employ a recurrent neural network to encode the video proposals, that event proposals, perform better than the max pooling approach. And they have the proposal model, and the proposed model is also able to detect sort as multiple overlapping events to and describe them. And this table shows the automatic scores reported by the proposed framework with other existing approaches. And this captioning model, which we have discussed here, still perform better than the other existing approaches. And one thing is that the evaluation scores for the generating description for still low, which needs to be addressed. In this given figure shows the general architecture of all the video description methods which employ deep learning approaches. In this figure illustrate the typical end-to-end video description system, which employ encoding process and the decoding process. In the encoding process, first different modalities are accepted, like 2D CNN feature, 3D CNN feature, semantic features, or the motion and the object features. Then it is followed by the transformation such as mean pooling, temporal encoding, or the attention proposal for visual events. In the encoding stage, the different variant of recurrent neural network is employed for the sentence generation, where the generation is initiated with the special start marker, and similar to image description, it will terminated with the special end of sentence marker, or when the sentence maximum length of the sentence is reached. Now, I will discuss our PLSTM framework, which we have proposed for VATEX 2020 Video Captioning Challenge. Basically, the objective of the challenge was to generate a suitable caption for a given video based on the content, event, and action in the Chinese or the English. To design a proposed framework for this challenge, we have focused on extracting comprehensive features and semantic representation to generate fluent and adequate description for a video in English. This given table shows the statistic of the dataset used for this challenge. In this challenge, basically two test set, the public test set and private test set was released, but the ground truth for this private test set was held out for the evaluation purpose. This given figure shows the pictorial representation of the framework which we have used. Basically, this framework includes the encoding and the decoding stage. In the encoding stage, we have firstly segmented the video into the chunks of a 16 frame, then using a 3D convolution neural network, the features for each chunks is accepted. And that to get a compressed visual representation, the dimension reduction is performed on each feature vector, and then they are concatenated temporally. Then in the decoding stage, two parallel LSTM are employed. The LSTM in the left take the embedded representation of the reference sentence as an input and the visual features in its initial state. While the another LSTM take the try to learn the cross-model representation by passing the concatenated, embedded, and visual representation as an input. And then finally, by performing a element-wise product between the output of both the LSTM and followed the output and followed by the softmax probabilistic function, the word with maximum probability is uttered at every time step. These are some quantitative results which are our model have scored on both public and private test set. Our model have reported 0.24 and 0.27 CDR score for both public and private test sets. And the description generated, the sample output of the generated description, we can see here that in the generated description, the model was able to address all the possible actions effectively, and the generated description have better fluency in and all the followed all the grammatical rules. And there are some other approaches which are proposed in that challenge are the multi-view features and hybrid evolved strategy for video captioning by Juetel and the multimodal feature fusion with the features attention for video captioning by Leonard. The system description paper of both the approaches are available in archive. Now the dataset available for the both image and video description. Basically, since the availability of a dataset play a crucial role in the success of a particular domain, so the dataset available for image description are Flickr 8K dataset. It includes benchmark collection of sentence and image pair, and it includes 8,000 images with 5 descriptions. Flickr 30K dataset is the extension of the 8K dataset, and the new images and the description focus on the pupil involving everyday activities or the event. MS Copo image description dataset. This dataset is basically provided by Microsoft in the and this is the largest available dataset for the image description. It includes around 80,000 images with 5 English description. Finally, the Hindi-English visual genome dataset. Basically, this dataset was provided into WAT 2019 for multimodal machine translation task, along with the task of describing a particular image in English or Hindi as well. Now, the dataset available for the video is summarized in this given table. The availability of labeled dataset for video description has been a driving force behind the fast advancement of this research area. And we can see that almost every year the number of datasets are proposed for the video description, but every dataset have some drawbacks. Based on the domains, we can categorize these dataset into 2 domains, like open domain dataset and the domain specific dataset. Basically, domain-specific dataset focus on the actions or the videos from particular domain. Like if you will see these MPI cooking dataset and you cook Tesco multi-level, they contain the videos from cooking domain to describe to generate an automatic recipe manual. But the open domain videos dataset include the videos from social media, YouTube, and the Vine videos also. And one thing, in generating a proper description, the availability of multiple references play a major role. And here, if we will observe this particular tables, there are only few data set are here which have multiple references. Now, the applications where a visual description can be used, it can be used in multimodal machine translation or the video guided machine translation for the disambiguation of the ambiguous word. For example, where for example, if you will take the previous machine translation approaches, they use to disambiguate a particular word, they use a context in which that particular word is appearing. But if you will take an example that Ram is going a bank, but if we will go for to find any context, we will not able to find any context in this sentence. But if we will have a associated visual scene with that sentence, we will totally able to disambiguate that particular bank, whether it is the river bank or the financial bank. Effectively generated description can be used for visual sentiment analysis, to for visual sentiment analysis, and the generated description can also be employed in indexing and retrieval of visual content, which we can verify from the discussed approach, that is the OSPAR or TenSCAP model. They have reported the benchmark results for image text retrieval or text image retrieval and the video retrieval also. It can be used in monitoring the suspicious activity in the surveillance security and generating a brief textual log for all the suspicious activity. And it can improve the effectiveness of AI system in understanding the visual entity with more effectiveness. Like it can be used in Google driverless car or chatbot also. Now, the challenges that need to be addressed in this field for the visual description. In context to video, since the video have multiple similar frames, it is still unsolved to select informative frame or decide the number of frames which are sufficient to generate a textual description. Uh, Temporal attention for text generation by with the preservance of the temporal order in which the particular action is occurring, and the evaluation matrices. Basically, currently to evaluate the generated description of a particular visual scene, we either use the automatic evaluation matrix or the human evaluation. In the automatic evaluation matrices, most of the evaluation matrices to evaluate the generated description are adopted from the machine translation field, that is the Blue, Roche, Meteor, etc. But and the human evaluation, we look for the coherency and the relevancy score, including the that corresponding to that image. But it get very time consuming when the number of images or the data in the test set are very large. Two evaluation matrices for evaluating the image description are currently provided. That is consensus based image description evaluation (CEDAR) and the semantic propositional image capturing evaluation (SPICE). But till now, though, no evaluation matrices is proposed by evaluating the description of video, because it would be challenging to describe a particular visual scene with just a single description, because based on the level of understanding of a person, there could be multiple way of describing a particular visual scene. So it is a challenging task to propose an evaluation matrix to evaluate the generated description. And still the evaluation, automatic evaluation scores for dense image description or the video description is still very low, that need to be addressed. So in summarizing the presentation, we have reviewed all the recent approaches for image and video description. Uh, we have analyzed the role of vision language pre-training in improving the performance of downstream tasks. Basically, all the vision language pre-training approaches which we have discussed take the image text pair as an input. But in the upcoming CBPR 2021, there are some approaches which are considering the video and the language pair for learning the cross-model representation. And the papers are available in archive. You can refer those papers. And we have discussed the application and the existing challenges of visual description generation. And in the acknowledgement, we would like to thank the SPARC and the MHRD Ministry of Government of India for sponsoring our work. And these are some useful links which you can prefer for your research purpose. That is the code for the BERT model is available in the GitHub by the Google researchers, and similarly for the VLP and Oscar models also. And this, thank you. Is there any questions?
Okay, so let's take some questions from the participants. Are there some questions?
Yes, sir. Sir, thank you for the good presentation. Sir, my question was that this visual description language which we are developing, sir, yes. Can this be utilized for all types of visual?
Sorry, hello. Can you repeat your
yes,
question?
Sir, based on the visual description which we are generating, this can be done for all types of visual images which are there, or are there any restrictions? For example, like factual images, or is there any for everyone we can develop a visual description?
Basically, the data set which are I've discussed, they include the images from wild. Basically, they include the actions or event from all the possible categories they try to cover, but still these models are not able to cover all the possible events. But to some extent, it can be it can generate a description for particular visual image. But you can there are some research is also going on that you can take the images from particular domain or describe a generation for the particular image.
Because see, it's a very interesting concept. If we have an image of, let us say, which is specific healthcare domain, I can take that image and create a visual description, and if I can proceed it towards any to other out of systems, then it can be a great help to the doctors as well. So that's what I'm thinking of.
Yeah, sure. Yes, sure. That's a nice idea. You can, if you will Google it, now there are many works which are describing the MRI images, which are generating a caption or the description for the MRI images or the other health-related issues. But for that, till now, what I have researched that no such specific data set is available for the health domain. If the data set will available, this work will almost work very effectively.
Okay, so basically the challenge is to first have a very good data set. Then only it can be fed to the system ultimately.
Yeah, because you basically know that deep learning approaches require a huge amount of data to learn. So you can firstly for that we need a data set, but you can try those data set which are the researchers are still doing. You can try those data sets.
Okay, sir. Thank you, sir. Thank you very much.
Any other query?
Let's take one or two questions, participants. If you have difficulty asking, please type in the chat box. I can read out the questions. So there is a question saying that what is the difference between semantic segmentation and image captioning?
semantic segmentation and the image captioning. Basically, in the image captioning, we focus on in the semantic segmentation, we just detect the objects and the attribute and describe them in the semantic words. But in the image captioning or the video captioning, we try to describe the whole scenario. What are the relationship among these semantic words or the objects, and also what they are action they are performing. Basically, this is the difference.
Okay. And how to measure over and under video segmentation?
Over and under video segmentation. Basically, can you elaborate this question? That
Dr. Pradeep, and can you please elaborate this question in live video stream? How to measure over and under video segmentation in live video stream?
Basically, if you will consider this video description approach for live, in that if you see this approach which we have discussed that by Ranjay Krishna et al., they have used the online context or full context mode. But in the online context, we will just able to use the information from the past. So this model can handle that the segmentation of the video in the real time, but this model will not able to address the
Hello.
Hello.
Hello. Can I interrupt?
Yeah. Yes.
Good evening, everyone. My question is that in the live video streams, for analysis and research purpose, how to make some sort of under segmentation and over segmentation, because video is nothing but the set of streams, set of images.
Yeah. Yes.
If I do store and do that processing, it needs a lot of time. If I store the video and convert that video into frames and do the over and under segmentation, it takes a time. I want to know that video analysis, some sort of segmentation in online, in whatever on the go.
Yes. Sir, basically, in brief, your doubt is that in the online live streaming, how we will do that the capturing process in the effectively or the in the instant. That is, we need no need to. That means that in brief, that you want to ask that in the live streaming.
Yes.
Yes, sir. Basically, in that way, if we will take this model, which is proposed by Ranjay Krishna et al., this model is using this online context mode. That means that this model will use the information from past event. So you can employ, and this model is not storing anything. This model is just with the will detect the event simultaneously, will describe that event.
Okay.
Basically, till now,
it will work for live stream also.
Yeah, it can work for the live stream also.
Okay. Thanks a lot.
Any other doubt?
Okay, so participants, we will take one or two questions now. Asking questions, you can type in the check box and I can read out for you.
You can ask any type of query. I will try to answer those queries.
Sir?
Yes.
Sir, for which software we should start with for this?
Sorry, your voice is breaking. Can you repeat?
Yeah. I'm asking which software we should start with.
I'm not able to understand what
Bonet,
you
can
are.
you please type your question in the chat box? Then I will read
Yes.
out. Your voice is breaking.
Okay, okay. Yeah, sure.
Bonet, did you type the question?
Which software we can
Question
start
from
with? Yes, sir. Hello. Am I audible? Hello.
Yes, audible.
I think your question is which software we can start with. Hello. One is one is.
Yes, your question is which software we can start with, right?
Software means basically till now I've not basically this questions regarding the software. You want to just simulate this description approach in the software, or you are asking about the platform or the what we can say libraries or we the models we use to design them. One is okay to design basically you can prefer the anything you can use MATLAB or the Python for the coding purpose, but for that you need a basic requirement. You need a data. You can download it from the if you are working in the images, you can download it from Google from the Kaggle. There are Flickr 30K and 80K 8K data set is available. And I've also shared the datasets or the link for the GitHub link from where you can start your you can start working on these models. Is it fine? Okay. The Pradeep's basically I've no idea about the fake news detection, but if you will go for the video fake video detection, so maybe the that selection of informative frames will be maybe helpful, but in detecting the fake video, uh, maybe you can in place of a fake video, you can for the forgery detection in the video, because detecting fake video, I have no idea about the how the we basically detect the fake news is or the fake videos. So sorry.
I have a suggestion for this.
Yes,
Just
sir. Yes.
actually, what sir is referring to is I think that how to detect fake videos specifically. So
Yeah.
I think digital forensics can be of
Yeah.
some help in
That was I was
that.
telling them that forgery video detection, or they can go for that those ones.
Yeah, and specifically there is a in that digital forensics, there is a even the digital and in this specific case.
Yeah.
That's it.
Alka Nanda have a question that is it used for reading languages? Yeah, basically for the image it is available. Many researchers from our institute also have proposed models for generating description in Hindi or the Bengali also. But you can for that and for in reference to video, we currently we don't have any data set. But in the upcoming month or the 2 month, we will release a data set on this also. You can refer that one.
Okay.
Is there any question?
We